All right, so today we're going to start looking at another type of function. So we've reviewed absolute value function, which gives us a V-shaped graph. Today we're going to be looking at quadratic functions, which means we have a degree of 2. Today we're going to focus on vertex form of the quadratic function. So f of x equals a times the quantity x minus h squared plus k, where a does not equal 0, and that is called our vertex form. The shape of our graph is a parabola. So a parabola is the shape of a quadratic function. All right, so determine each of the following for the parent function f of x equals x squared. So we're going to start off, we're going to actually make a table. I'm going to kind of squeeze this in here. So we can figure out what the shape of this parabola or quadratic function looks like. So we're going to use our x values, -2, -1, 0, 1, and 2. Okay. So if we plug in -2 squared is 4. So then our ordered pair becomes -2, 4. All right. -1 squared is 1. So we have the ordered pair -1, 1. 0 squared is 0. So we have the ordered pair 0, 0. 1 squared equals 1. So we have the ordered pair 1, 1. And 2 squared equals 4. So we have the ordered pair 2, 4. All right, so if we go over to this coordinate plane and plot these points, so -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Okay. So it doesn't make a V because that slope is not consistent. So we're actually going to curve this line to make our parabola. So this is often a U-shaped graph, or called a U-shaped graph. Okay. All right, so now let's talk about the key features of this graph. So review in behavior. Remember, in behavior, we're looking at our arrows at the top or the bottom. So this is going to be 2 arrows facing up or up, up. Okay. Our vertex is where our bottommost part of our graph is at, which here is going to be 0, 0. Our axis of symmetry is still the line that cuts the graph in half. Okay, and that line would be x equals 0. And remember, we graph that with a dashed line. Okay. And then let's see here, as we continue, is this a maximum or a minimum value? Since we have a bottommost point of our graph, this is a minimum. And we're going to be talking about what that minimum value is. It's actually going to be 0. And it is always the y value of the vertex. Okay. Now we want to look at our x-intercept and our y-intercept. So our x-intercept is wherever it crosses the x-axis, which is at 0, 0, which is the same as our y-intercept. Our domain is going to be -infinity to +infinity. And then our range, we're going to do the same as what we did with our absolute value function. So our bottommost y value is 0, and we're going up to a +infinity. All right. So with that, graphing quadratic functions, we can also use transformation. So this is going to be the same as what we did with our absolute value function. So if we go through here, remember on the inside, x minus h. Okay, so this is our horizontal translations. And if it's positive, we're going to be moving to the left. And if it's negative, we're going to be moving to the right. The plus k on the outside is our vertical translations. And if it's positive, we're moving up. And if it's negative, we're moving down. Then our a value in front, we have a couple of things that come from that. If a is greater than 1, I'm going to say the absolute value of a, we have a vertical stretch. And if a is in between 0 and 1, then we have a vertical shrink. Okay. Also from our a value, if a is less than 0 or negative, then we reflect the x-axis, meaning that our parabola is now facing down. Okay. So all of those rules are the same as what we saw. The only thing that has changed is instead of the absolute value bar, we have a squared. And what that squared does is that determines the shape of our graph to be a parabola.